Section 2.6, State Functions and Path Functions. State functions depend on the state of the system. It does not depend on how the system reaches the current state. For example, the pressure, volume, temperature, entropy, internal energy, enthalpy, Helmholtz free energy, Gibbs free energy, and the number of moles are all state functions. They do not depend on how the system reaches the current state. They just depend on the current state. The differential of a state function is exact. That means we can integrate the differential of a state function given only the lower and the upper limits of the integral. The cyclic integral of an exact differential is always zero. This is because the change of a state function is the integral of the exact differential of that function. Therefore, it's just U final minus U initial when we're talking about internal energy. If the initial state is the same as the final state in the cyclic process, then of course the cyclic integral is just exactly zero. And you can replace this U internal energy with any other state function. The two equations will hold true. What about path functions? They depend on the path of a process. For example, heat and work. The differential of a path function is inexact, and we cannot integrate those inexact differentials given only the lower and the upper limits of the integral. We have to know the entire path, the integral path or the process. We need to know how the system changes from its initial state to the final state. And the cyclic integral of an exact differential is almost always non-zero.